In this video, I'll be solving Math 2B Midterm 2 that was given in fall of 2017. Okay, so I have not seen any of these problems. I'm going to be solving them live as if this were the exam, okay? So hopefully this helps you see how I tackle the problems. Okay, so let's begin. 1a, we're asked to solve cosine to the fifth, sine to the fourth, dx. This one is easy because we know that whenever there's an odd power, we want to save one of those factors. Okay, so the cosine is an odd power, so we save a factor of cosine, like this. Okay? If they're both odd, doesn't matter which one you pick. If there's only one odd, you have to pick that one. Okay? And then we use the identity sine squared x plus cosine squared x is equal to 1. We're going to use that to change this guy to be... Okay, well, we want to use that because we want to have a du is cosine x dx, meaning our u is sine x. So we want to get this cosine to the fourth in terms of sine. And we can do that by doing 1 minus sine squared x squared sine to the fourth x cosine x dx. This is cosine squared by the identity. Cosine squared squared, that's cosine to the fourth. So here we let u be sine x. Du would be cosine x dx. Okay, so we substitute everything in the integral in terms of u. We get 1 minus u squared squared u to the fourth du. Okay, and that's expanded out. It'll be 1 minus 2u squared plus u to the fourth du. We can distribute. I'm going to do 2 steps in one. Distribute, and then take antiderivative of u to the fourth. That's u to the 5 over 5. Minus, this would be u to the 6. So antiderivative of u to the 6 is u to the 7 over 7. Okay. This one would be u to the 8th, so antiderivative would be u to the 9th over 9, plus c, and then we had to back substitute our u, so that would be sine to the 5th power, minus 2 7th sine to the 7th power, plus a 9th sine to the 9th power, plus some constant c. That's our answer. Okay, so this one's easy because there's an odd power of cosine, so we save it. Okay, that was the technique there. Let's move on to 1b. That is integral arctan x dx. This one, if you've seen it before, you know it's integration by parts. If not, let's just go down the techniques. Substitution, probably not, because if u is arctan, du is 1 over 1 plus x squared dx. There's nothing like that here. It's not a trig integral of sine and cosine, or secant and tangents, so not that. Not trig sub, definitely not partial fractions. So we're left with integration by parts. So we have to set a u and dv. So how do we set a u and dv? If we set dv to be arctan x, we would have to find integral of that for v, which is the same thing. We don't know how to do that. So we have to let arctan x be our u. So our du, we know how to do that. That's just 1 over 1 plus x squared dx. dv is whatever is remaining. So v is x. Okay, so the integral is equal to uv minus v du. So x, arctan x, minus integral of x over 1 plus x squared dx. This guy we know how to solve. That's just a simple substitution of u is 1 plus x squared. Du would be 2x dx. So this would be minus integral of half du over u. Okay? So this is just x arctan x minus half. This would just be the log. And that log of u is 1 plus x squared. I'm going to do 2 steps in 1 plus c. That's our answer. As simple as that. Okay. Let's move to the next problem. Okay. So, I don't know why this always doesn't work well. Okay, there you go. Let's go to 1c. We are given integral 4x minus 7 over x squared minus 5x minus 4 dx. This one's probably partial fractions because it's polynomial over a polynomial. It's not substitution because if you let u be the bottom, du would be 2x minus 5 dx. Doesn't look like that really. Okay. So we do partial fractions. 4x minus 7 over, if we factor the bottom, that would be x minus 4, x minus 1. So partial fractions would be a over x minus 4 plus b for x minus 1. Okay? And then we multiply both sides by this denominator. We get 4x minus 7 is equal to a x minus 1 plus b x minus 4. Okay, so the quick way to solve for a and b, we set x is equal to 1. Then this term would go away. We get minus 3b is equal to minus 3. So b is equal to 1. We let x is equal to 4. We set x is equal to 4. This term goes away. 3a is equal to 16 minus 7. That's 9. A is equal to 3. So we can rewrite this as 3 over x minus 4 plus 1 over x minus 1 dx. This is easy to solve. That's just 3 ln x minus 4 plus ln x minus 1 plus c. That's our answer. Okay. Next. We have this integral. So just by process of elimination, what have they not tested us on yet? They haven't tested us on trig sub yet, so that's probably what we use here. And that's what I would use, because it's something squared minus something squared under a square root. Okay? So we set up a triangle. We know that 2 has to be the hypotenuse, because it's something squared minus something squared by the Pythagorean theorem. This first term has to be the hypotenuse. And then we know that we have x as one of the sides, and square root 4 minus x squared is the last side. So if you use the Pythagorean theorem, this would work out. Okay, so we want to set everything in this integral in terms of theta, integrand in terms of theta. So we have to get dx. How do we get dx? We have to get x first. We know that sine theta is x over 2. So 2 sine theta is equal to x. 2 cosine theta, d theta would be dx. So we got dx. How about this term? We can get that by 2 cosine theta is square root 4 minus x squared, because cosine theta is this over that. So just move the 2 over. Okay, so we can substitute everything in this integrand in terms of theta now. So we have dx is 2 cosine theta d theta. The bottom would be 2 cosine theta cubed. Okay, so we can simplify. We know that we would have, the top would cancel with one of these. So we would have 1/4 integral of secant squared theta d theta. Cosine squared is at the bottom, and a 2 squared is at the bottom, so 2 squared is 4. So we factor out the 1/4, or we move it to the front. And then 1 over cosine squared is just secant squared. This we know the antiderivative of. That is just 1/4 tangent theta plus c. We have to substitute though. We can get theta from a triangle. That's just 1/4 x over square root 4 minus x squared plus c. Okay? That's our answer. Okay, so that was number 1. Not bad at all. Okay. Let's move on to the next problem. I don't know why he skipped from 1 to 3, but let's just do it. Okay. and then he crossed out the original problem. Okay, so I guess we're solving this integral. So it tells us to solve the improper integral, so we know it's improper. Okay. This is improper because as it goes to 3, then this guy would go to 0. So 1 over 0, infinity, right? That's why it's improper. So we can rewrite this as limit as t goes to 3 from the right, integral of t to 4, 1 over x minus 3 dx. Okay, we write it like that. Now, this integral is easy to evaluate. That's just ln x minus 3. We evaluate this from t to 4. Okay, so we get limit as t goes to 3 from the right of ln of 4 minus 3 is 1 minus ln t minus 3. Okay, this guy is simply just 0. Okay, so we have minus limit as t goes to 3 from the right ln t minus 3. Okay, what's this limit? Well, we know the natural log. This is just a natural log shifted to the right by 3. So it looks something like this, right? There's an asymptote at x is equal to 3, or t is equal to 3. So as we approach t from the right, we're going to minus infinity. So this guy's minus infinity, but we have another minus sign, so it's going to positive infinity. So it's divergent, and it goes to positive infinity. Okay? Next. We have this improper integral, x e to minus x dx from 0 to infinity. This one, if you recognize, is integration by parts. So let's do that. U and dv. Remember, for this type of problem, we want to reduce the x. So we let it be u. So du would be dx. dv is e to minus x. V would be minus e to minus x. Oh, sorry, there should be dx there. Okay. Integration by parts. We get minus x e to the minus x. Evaluate this from 0 to infinity. Plus, because it'll be minus a negative, so plus. That'll be e to minus x dx from 0 to infinity. Okay, that would be minus x e to minus x. We integrate this, we would get minus e to minus x, so this whole guy from 0 to infinity. Okay, so let's write it in limit notation. Limit as t goes to infinity of minus x e to minus x minus e to minus x from 0 to t. Okay. So let's do the fundamental theorem of calculus. Limit as t goes to infinity of minus t e to minus t minus e to minus t minus, when we plug in 0, we get 0 times something, which is 0. 0 times 1, which is 0. And this is 0 minus this guy is still 1. Okay? So we can say this would become positive 1. It will be 1 plus limit as t goes to infinity of minus t over e to minus t, and then plus limit as t goes to infinity of minus e to minus t. Okay, we can break up the limit like that. We distribute, but not distribute. We can, by properties of limits, take the limit of this, plus limit of this, plus limit of this. That's what we did here. Okay? So, when we evaluate this limit, what happens? Let's use L'Hopital's rule. Derivative of the top would be minus 1. Derivative of the bottom would be minus e to minus t. as t goes to infinity for this, e to the minus infinity, as t goes to infinity for e to minus t, this value goes to 0, right? E to the minus infinity is 0. So we get plus 0. And this guy, as t goes to infinity, this guy also goes to 0. Okay? So we are left with 1. It converges to 1. Okay? That's how we solve this problem. Let's move on. Now we have to find whether these sequences converge or diverge, okay? A sub n is 2 plus minus 0.5 to the n. Okay? So how do we solve this? To see if it converges, its limit as n goes to infinity of a sub n. Okay? We know this is 2 plus limit as n goes to infinity of minus 0.5 to the n. Okay? Limit of a constant is just a constant, so we already evaluate the limit of this guy. Okay? This guy, because it's less than 1, excuse me, we know that it converges to 0. So that'd be 2 plus 0, which is 2. So it converges to 2, this sequence. Next, a sub n is natural log of 2n to the 4th minus 3n squared plus 2 over n to the 4th plus 1. Okay? We know that limit as n goes to infinity of a sub n, we want to find that. We can say it's natural log, but remember properties and limits, we can do this. Plus 2 over n to the 4th plus 1. We can do this. Okay? How do we find the limit of the inside? Well, you can do L'Hopital's rule, that's fine. You also can remember this is just a horizontal asymptote. So we do the degree test, the degrees are the same. Take the ratio of the leading coefficients, that's just 2. So ln of 2 would be what it converges to. For C, a sub n is ln of n over ln of 2n. So limit as n goes to infinity, a sub n. Let's do, well, when we take the limit as n goes to infinity, it'll be infinity over infinity. So indeterminate, let's do L'Hopital's rule. Derivative ln of n is 1 over n. Derivative ln of 2n is 1 over 2n times 2. So these would cancel. These would then cancel. So I don't know why I put that limit sign there. So limit as, oh, actually, yeah. I forgot to do the limit notation. And it goes to infinity of this guy. So have a good notation. So it becomes limit as n goes to infinity of some constant 1. So that value is just 1, converges to 1. Okay. For the limit, a n is cosine to n over 2 to the n. How do we solve this? Well, we have to use squeeze theorem for this. Okay, we know that cosine of n is between 1 and minus 1. The cosine function is always between that. So we multiply everywhere by 1 over 2 to the n, so minus 1 over 2 to the n is less than or equal to cosine n over 2 to the n, which is less than or equal to 1 over 2 to the n. Okay, we know that limit as n goes to infinity of minus 1 over 2 to the n, that's simple, that's 0, because the bottom gets bigger and bigger. Limit as n goes to infinity of positive 1 over 2 to the n, that's also 0. So by squeeze theorem, limit as n goes to infinity of a sub n, that's also equal to 0. So it converges to 0. Okay, that's how we solve that one. And the last problem for E. This is very quick. It's only 20 minutes so far. Limit, an, and we're not doing limit yet, minus 1 to the n over n factorial. Remember, we can do limit as n goes to infinity of absolute value of a sub n. If this guy converges, then without absolute value it also converges, okay? So we get limit as n goes to infinity of 1, absolute value would get rid of this changing sign, 1 over n factorial. Okay? This guy, because it's n factorial, so as n gets bigger, this will get, the denominator will get bigger and bigger, so the value will get smaller and smaller, this conversion to 0. So limit n goes to infinity of a sub n, no absolute value, is also equal to 0. So it's conversion to 0 also. Okay? So this is a very easy midterm actually. So hopefully everything was clear. If not, just feel free to leave it in the comments. Otherwise, if this video has helped you in any way, please hit that like button and please subscribe to the channel for more videos like this.